Okay. I think we're live. Let me check my audio as well if I'm audible. I think we're live. Yeah, I think we're live. So hi everyone, and I'm sorry that I couldn't actually remove my background today because I'm not at home. I'm using my friend's setup for this. But I hope that I'll be able to explain the problems if you weren't able to solve this. And I even saw a couple of you actually have joined the stream around 10 minutes before it ended. So just curious, why did you uh, I'm hoping that the problem set I have seen, it is easy. So I believe that you have solved all the problems and you are here for the discussion. But again, thanks, Take Give. Thanks for informing. So yeah, so let's start with the discussion for the day. And I'm really sorry about if you don't like the background or something. I'm not at home right now. I'm in a small trip with my friends, but again, I had to do this. So yeah, let's continue with this setup. And from I think uh next in interview series, I think we should be fine. Let's see. Let's hope for the best, right? So let's start with the problem. So the first problem that we have is nearest smaller tower, right? So what does it tell? It tells us that you are given an array where each element ARRI represents the height of the tower at position I. For each I, we need to find the nearest index j. J is greater than I or less than I. That is, either j is on the right hand side of I or j is on the left hand side of I, whose height is less than the height of the current tower. That is, ARR of j is less than ARR of I, right? So if there are two such towers that are existing, one to the right and one to the left, then you and both are at the same distance, then you have to choose the smaller one. Otherwise, if they but if those two towers have the same height, then choose the tower with the smaller index, right? So what you basically have to do is, for every element you have to find what is the next element, or what is the previous element that is nearest previous element, or the nearest next element that is less than the current element, and if there are two elements that are at the same distance, right? So you're taking the nearest one out of them. Now the condition will be if they are at equal distance, like on the left as well, on the right as well, and on the left as well. In that case, you have to take the one that has what? That is the smaller one, right? And otherwise, you have to choose the one that is on the left hand side. If they have both of them have the same height, you have to choose the one with smaller index. Smaller index basically means the index, right, of the left hand part. So that is the question. How would you solve this? Anyone? We can take an example here like 132. For 1, we do not have any element on the left as well as on the right that is less than 1, right? So it's -1 for 1. For 3, it is 0. So 0th element is the nearest one that is less than it. And for 2 as well, it is 0 because it is the nearest element that is on the left hand side that is less than 2, right? 3 is not less than 2. Good evening. So let me know if the question is clear with everyone, and if the question is clear, how would you solve this? Any ideas? How many of you have solved this, and how would you solve this? Can you tell? So we can take this example as well. 48653. 48653. Let's take this example. So we have 4, 8, 6, 5, 3, right? So for 4, we do not have any element on the left. So we will only focus on right. On the right, what is the nearest element that is smaller than 4? 8 is not, 6 is not, 5 is not, 3. So the index is 0, 1, 2, 3, 4. So for 4, the answer will be 4, right? The index 4, that is 3. For 8, we have 4 on the left, 6 on the right, that are nearest smaller elements. Now they both of them are there, right? Now as both of them are at the same distance of 1, like 4 is 1 unit on the left side of 8, and 6 is 1 unit on the right hand side of 8. So the distance is same. Now if the distance is same, we'll take care of the height, right? The height is 4 is less, right? So we'll take 0 here. For monotonic stack, question is clear. Okay, using stack we can solve it. Okay, monotonic stack, one from start, one to end, and reverse. Yes, and naive approach takes n square. And Darshun couldn't solve it. That's totally fine. We'll solve it right now. Don't worry about that. So for 6, 4 is there. And on the right, what is less than 6? 5. So 5 is nearer, right? So we'll just take 3 as the answer. For 5, on the left, there is 4. On the right, there is 3. So 3 is nearer. So we'll take 4, the index. And for 3, on there is nothing less. So minus 1. So 4034 minus 1 should be the answer. We can see 4034 minus 1 is indeed the answer. So for this, it actually is very simple. How is it simple? If you have already, I have already a video in this channel discussing about next greater elements and variations, right? So this is a variation. If you have attended that lecture or if you have seen that video, this was a cakewalk problem for you, because I've discussed exactly this problem there itself, right? So we, if you already know, I will not be discussing about a next greater element, how next greater element works. It is a very standard algorithm. You maintain a stack. The stack is maintained in a certain order. Like you assume that only those elements are there whose next greater element is not been found yet. Now, what do I mean by variation, right? What do I mean by variation? Here, the problem is basically you have to find the next lesser element. You have to find the next lesser element. Next lesser element. Similarly, that is for the right hand side. For the right hand side, you have to find the next lesser element. For the left hand side, how would you do this? For the left hand side, we can use the PLE, that is previous lesser element concept. Previous lesser element. What is exactly previous lesser element? The same definition, like what is the element that is previous to the current element, that nearest element previous to the current element, that is lesser than the current element. Now we know that there is already a relation between previous lesser element and next lesser element, right? How do we form that relation? Previous lesser element, if you see the previous lesser element for a given element is the next lesser element in the reverse order. In the reverse array, it is equals to the next lesser element. So previous lesser element, we know that previous, or we can see that previous lesser element is equals to next lesser element on reverse array, right? On reverse array. So we just have to focus on next lesser element, finding next lesser element, and previous lesser element follows that, right? Why is that? Because previous lesser element, what is the meaning of previous lesser element? The element on the left hand side, the element on the left hand side, nearest element on the left hand side, that is less than the current element, right? What is next lesser element? The nearest element on the right hand side. On the right hand side, that is lesser than the current element, right? So if you reverse the array and then you find the next lesser element, and then you reverse the next lesser element array again, so that you actually map it to the existing array, doesn't it actually give you the previous lesser element? So in the reverse array, the previous lesser element basically becomes the next lesser element, right? So you just have to find the next lesser element, and you have to find the previous lesser element. How do you find the previous lesser? You have to only have one method, next lesser element, and you have to call the next lesser element with the reverse array, and then when you get the answer array, previous lesser element array, you have to reverse it again to get the actual answer, right? Because this is next lesser element on the reverse array, but your array is straight, right? So you have to find it on the straight array. So does this make sense? Is it clear with everyone? How do we solve this problem? Dashun, is this clear with you? Others who were not able to solve or who had naive algorithms, is it clear how we can solve this? I'm hoping that you already know about next greater element. You already know about next greater element. Next lesser element is nothing. It's same as next less greater element, only the condition will differ, right? Only the condition will differ. So it's the same logic that happens. Is it clear with everyone? Let me know in the chat. Write yes if it's clear with you. Write no if you need more explanation, or if you need write the part which you need more explanation on. I'll be definitely happy to help you here. Please let me know in the chat. It's clear now? Okay. Awesome. Awesome. Should we move to the code? Yes. Should we move to the code? Okay, it's clear. So, okay, please do write down on what you're saying. Sure. Sure. Let's do that. Let's do it on this array itself, because we know the answer for this array. So let's just do it for this array, right? uh, uh, NLW means the runtime is order of n. The space complexity and time complexity both will be order of n, because next greater element works in order of n, right? We'll use the same algorithm, same thing, only the condition and the loop will differ. Only the condition will differ. For next lesser element, only the condition. If you remember the condition of next greater element, what did we have? We had while not stack dot empty, something like this, right? Stack is not empty, and we had some condition like the ARR of stack dot top. What did we remove? We removed the array was like we were finding next greater element, right? So only array contain elements that are less it should not contain greater elements. So we'll remove if the element on the top, if it is lesser than the current element ARRI, right? Because you have found the next greater element. So this was the condition, right? For next lesser element, we will just reverse this condition. For next lesser element, we'll just reverse this condition. It should be greater than, and that will basically give you the next lesser element. Yes, let's try it on this once, right? Let's try it on this once. I'm assuming that you already know about next rate element. Let me know if you don't know about next rate element. If you, and definitely you can go through the video of me as well. I think I've explained there properly about this. Okay, so let's start for this array. 0, 1, 2, 3, 4. Okay, for 4, what is the next lesser element, right? So what do? We push it into the stack, right? We push it into the stack. So we push, as the stack is empty, we'll push 0 into the stack. After that, we have 1. We are at 1, right? We are at 1. Let's write it in green. We are at 1, or this is blue actually, sorry. We are at 1. uh, is the element on the top of the stack? The element is the index, right? Here index is there, but we'll compare the elements. So the comparison that we'll look for is ARR of stack dot top. Stack dot top, if it is greater than ARR of 5. This is the comparison we'll look for. ARR stack dot top is greater than ARR of 5, then we'll remove from the stack. So is the element at index 1, that is 8, is 8 less than ARR of I is 8, is less than the top of the stack, that is 4. ARR of 0 is 4, right? ARR of 0 is 4. Is 4 greater than 8? No, right? So we will just push 1 into the stack. 1 is just pushed into the stack, and we'll continue our loop. So 1 is pushed into the stack, we'll continue our loop. We'll go to this. Is the element on the top of the stack, that is 1, is the element on the top of the stack, that is index 1, that is 8. Index 1 is 8, element at index 1, 8, right? Is 8 greater than the current element, that is 6? Yes, it is greater than. So we will remove it from the stack. We'll remove it from the stack, and we'll mark its next lesser element to be index 2. We'll mark its next lesser element for 1, index 1, to be index 2. That is for 8 will be, it will be index 2, that is 6. 6 is the nearest lesser element, next lesser element, right? So now on the top of the stack we have 4, that is index 0, we have 4. So we will just push into the stack. So 6 is pushed into the stack, that is 2 is pushed into the stack. We push the indices, right? We'll push the indices. We'll not push the array values. So after that we'll go to 5. After that we'll go to 5. Is the element at the top of the stack, that is 6, greater than 5? Yes. 6 is greater than 5, right? Element at the top of the stack is 6. How? Because index is 2, right? Index is 2 means 6 is there, is the element that we're considering. So 6 is greater than 5. So we'll remove it from the stack. We'll mark next lesser element. This is next lesser element. Next lesser element of 2 to be index 3. And we'll then on the top of the stack we have 4. 4 is not greater than 5. So we will just push 3 into the stack. We'll just push 3 into the stack. After that we'll go to 3. Now element at the top of the stack, that is element at index 3, that is 5. Is 5 greater than the current element, that is 3? 5 is greater than 3, yes. So we will remove 5, the index from the stack 3. We'll mark next lesser element of 3 to be the index 4, right? The index 4. And then we will again we come again to the top of the stack. What is at the top of the stack? Index 0, right? What is index 0? 4. Is 4 greater than ARR of I? Is 4 greater than 3? Yes, it is. So we'll remove that as well from the stack, and we'll mark the next lesser element to be index 4. And now it is empty, so we'll push 4 into the stack. Now as the loop is completed, so this will be marked as -1. So if you see that the next lesser element is found. Okay, I think I lost my connection, but again I'm back. Let me know if you see me again. Yeah, I think I lost my connection. Yes, yes, I think I'm back. Yeah. So for I think next lesser element is clear with everyone. So we'll move to the next one, that is previous lesser, and it's basically same. Just try it on your end once. Just find the next lesser element. We'll quickly do that. So for the reverse array, we'll find the next lesser. So the reverse array is 3 5 6 8 4. So for this array, we'll find the next lesser element in the same way. So what will be the next lesser element for this array? For 3, it will be index 0 1 2 0 1. Acha, this is when you mark the index will be, as the array is reversed, the index will also be reversed. So you have to mark the index in a reversed way. So 0 1 2 3 4, and the index that you will mark is n minus I, because the array is reversed, right? So for 3, the next lesser element doesn't exist, so -1. For 5, the next lesser element will be n minus I, that is next lesser element is what for 5? 4. So 4 minus n, that is 0. So next lesser element previous is 0, right? And if you see for 5, the previous lesser element is indeed 4, right? Index 0. So you can just mark it to be n minus I. So this is how you can do, or you can do it separately as well. Just run a reverse loop and then do the next lesser element. That will actually that will also work. So we can do it either way, right? We can do it either way. So I'm not going into this. You can definitely try this on your end. I'm not going into details. Let's go into the code for this. I think it should be clear. So yeah, let's take. So vector int arr we have. Let's take the stack. Let's go for full screen mode right now. Stack int x and arr.size and vector int next. Can you guys let me know once if my stream is freezing for you? Like it's showing me loading on my device. Is it freezing? Is it reloading every minute? Is it loading again and again? Let me know in the chat once. Is my internet causing problem? Let me know if my internet is causing problem. Next lesser element n plus. Oh, it is causing problem, right? So just wait for a moment. Okay, just wait for a moment. Let's hope that it works now. Let's hope that it works now. So uh okay, next lesser element n plus 1. Initially we'll have or we're gonna have n as well, n minus 1 initially everything. uh Also we'll need previous lesser element, right? So vector int previous lesser element n and -1. Okay, so we are just initializing with -1. So let's just run with our loop. So we'll run our loop from 0 to n minus n, I 0 I less than n I plus plus. We'll check what is the condition that we check, while not stack dot empty. So while not x dot empty, while not x dot empty, and arr of x dot top, arr of x dot top is greater than ARR of I. ARR of X dot top is greater than ARR of I, right? In that case, what we'll do? ARR of X dot top is greater than ARR of I. In that case, we'll do ARR of X dot top, sorry, next lesser element of X dot top, whatever is the index, is equals to I and X dot pop, right? X dot pop will pop it from X and we'll push it here. X dot push I. X dot push I. Okay. So this is the code for, I think this is the code for next lesser element. So we can empty the stack quickly. So while not X dot empty, we can pop it X dot pop so that we have emptied the stack. Now we'll go for the previous lesser element. We'll use the same logic again. We'll use this very same logic again, but we'll just run a reverse loop. So let's just copy and paste this. We'll just run a reverse loop because it's same, like reversing and finding next lesser element. Instead of that, just run a reverse loop. That's the same thing, right? So I greater than equal to 0 and I minus minus. I minus minus, right? X dot top and X dot push I. Yes, that should be it, right? So we have find the, and this should not be NLE, this should be PLE, previous lesser element. So PLE. And now what we can do, we can go for all the elements once. So we have to find the answer, right? So vector int answer n minus 1 for int I equals to 0, I plus plus. If both are minus 1, then we'll continue. If NLE of I equals to minus 1 and PLE of I equals to minus 1, then we'll continue. We'll just continue with the loop. Otherwise, what we'll do, we'll see if one of them is minus 1. So if NLE of I equals to minus 1, if NLE of I equals to minus 1, then what we will do, answer of I will be equals to PLE of I. Else if PLE of I is minus 1, then answer of I is equals to NLE of I. Otherwise, if both exists, then what? We'll choose the one with what? We'll choose the one with lesser height. So first of all, we'll check the distance. If the distance is same, so how do we check the distance, right? How do we check the distance? I minus NLE of I. Sorry, NLE is greater, right? So NLE of I minus I is equals to PLE of I is greater than PLE of I minus PLE of I is greater than I minus PLE of I. Then answer of I equals to what? It is greater, so we'll choose the nearer one. So PLE of I, or what we can do is we can check for here less than, otherwise it will always be NLE, right? It will always be PLE. So it will be NLE of I, otherwise it will be always PLE. Else, because then it will be lower, or will it be? No, there can be equality as well, right? So let's check for the second condition as well. Else if is greater than, in that case answer of I is what? Answer of I is equals to PLE of I. PLE is nearer, right? In this case PLE is nearer, previous lesson is nearer. Else it is equal, both are equal. In that case, if ARR of NLE of I, if ARR of NLE of I is greater than, is less than ARR of PLE of I, then answer of I equals to NLE of I. Answer of I equals to NLE of I. Else answer of I equals to PLE of I. PLE of I. Right. So this is the entire logic, I think. So we can return answer from here. We can return answer from here directly. So we can try compile running. I think it should take the smaller one, right? Same distance, choose the smaller one. But if two have same height, then choose the tower with previous smaller previous index, right? So if their distance is same, then if NLE of I or NLE of I, that is next lesser element has a smaller height, in that case answer of I equals to NLE of I. Otherwise answer of I equals to PLE of I, right? So we can compile and run. I'm not sure why it's not running. -100, I think that's expected. Let's try for the second case as well quickly. uh let's try for this as well, just to be sure if it's working fine. So my output, okay, 1 2 3 -1, and it should be 1. It's giving 1 for what? For 4 it is giving 1. What was our condition again? We're pushing I, right? And error x dot top, the top element is greater than error of I. So the top element, we are finding a lesser element, right? We're finding a lesser element. Yes, we're finding a lesser element greater than error of I. Okay, 1 second. 1 2 3 -1. Answer equals to NLE of I. 1 2 3 -1. I think for it is giving 0. It should be 0 for 8. It is giving 2. That is 6. For 4 it is giving 1. That is 8. How is 8 coming even? So if NLE of I equals to -1. Okay, it is coming to next. Previous lesser is -1. Answer next lesser element. So next lesser element is this one, right? I while not x dot empty and error x dot top is greater than error of I. NLE of x dot top equals to I and x dot pop, and we'll push into this, right? So that's there. So let's print the NLE array, right? For int I equals to 0, I less than n, C out NLE of I, and C out slash n. Let's compile and run against this. Okay, we are getting 1 2 3 -1 in NLE. How are we getting that? Error x dot top I equals to 0. Vector int error is given to be 48653. First line contains input and containing n size of the array. So the size of the 1 2 1 2 3 4 5. So it's 5. I think my input was wrong. So I think now it should work. Okay, 4034 -1. It is coming correct. So let's try submitting this now. So let's submit this. Okay, problem solved. Okay, so I think it's done, right? It's done. So Let's go to the second one, coding problems. Let me know if you have any doubts with this one, right? So this condition is a bit tricky. Like you are just checking if the next lesser, which one to take, the next lesser element or the previous lesser element. So you just have to do whatever is told here. If you have to take the nearest one, if they are at the same distance, then you choose the maximum height. Otherwise, you choose the minimum height. Other you choose the minimum index, right? So we are doing exactly that in this entire set of code, this part, right? So nothing else is we are doing. So let's go back. And second is job sequencing. Has anyone tried job sequencing? And how many of you were able to solve this? Let me know. And how would you solve this? How would you solve this? How would you solve job sequencing? Any ideas? So let's read the problem statement. Given you are given n jobs, where each job I has a deadline and a profit associated with it, right? So each job has some deadline and there is some profit. Each job takes 1 unit of time to complete and only one job can be scheduled at a time. We earn the profit if and only if the job is completed by its deadline. The task is to find the number of jobs done and the maximum profit, right? So your task is to maximize your profit. Just, yeah, I think, okay, Hemant, okay. Worst case was n squared, but passed. Are you sure it was n squared? I'm not sure. Left smallest and right smallest. Yes, I think it will be n squared using DP, right? So yeah, might be luck, or might be that I'm not sure if the test cases was strong. I'm not sure about that. So if n squared is passing, probably it was not very strong, right? So it was probably not very strong. So yeah, so you're given n jobs and each job takes 1 unit of time to complete. So you are given a deadline against each job, and also what is the profit that you can earn if you do that job within the deadline given. So your task is to maximize your profit and also tell you how many jobs will you do in the same, right? So jobs are given in the form of job ID, deadline and profit. So n equals to 4, jobs will be 1 4 20 2 1 10. These are the job IDs 1 2 3 4. Next is the deadline. It has to be completed within 4 days, 1 day and 1 day, and the profits 10 40 30 20, right? So what you can do is you can complete two jobs, because see, you have to complete within one, right? Within 1 day you have to complete all these three jobs, right? 1 day is in day one. Let's consider days, right? From starting day, it is day one, day two, day three. So you have to complete everything within day one. All of this you have to complete within day one. Okay, all of these you have to complete within day one. So that's why you cannot complete all of them, right? At one point of time you can only do one job, and each job takes 1 day, right? So you have to choose out of them. So the best choice is to choose this one, 3 140, and then you can also do this 1 420, because this is within your deadline as well. After the first day you can do it on the second day. So and you have to do it within the fourth day, the deadline, right? So 40 plus 20 is 60, and you are doing two jobs. You cannot do the remaining, right? You cannot do the remaining. Similarly, n equals to 5 here, and the corresponding data is given to you. So this job has to be done within day 2. This job has to be done within day 1. This again has to be done within day 2, day 1, and day 1. So you can again choose two out of them, right? You can again choose just two out of them. Which one? Like day 2 you can choose this one, or the maximum one for day 2, that is 100. And for day 1 you can choose the maximum one to be, like, let's say 15 25 15, right? So for day 1 you can just choose the maximum, that is 25. So 100 or 125 is done. And also you're doing for 5 days, right? So 2 1 2 2 1 1. Okay, so how is it? Okay, you can choose 27. There is a 27 as well, right? So, but it has to be done within day 2. So you can do this within day 1, right? You can do the first job within day 1 and second job within day 2. Both are within deadline then. Because day 1 you are not taking any job at all. You have the deadline for day 2, but you can definitely do it before your deadline. So you will just do it on day 1, right? And for this you will do it on day 2, right? You will just do it on day 2, or this one on day 2 and this one on day 1, whichever works for you, right? So how would you maximize your profit? How would you maximize your profit? That's the question. So this is actually an interesting problem. Let's discuss about this. How can we do this? Okay, so we are given some things, right? We are given some data with us, that is job ID is not relevant, it is kind of the index, right? So we have two data points, that is what is the profit that I earn, right? What is the profit that I earn versus what is the deadline for the given task, right? Deadline for the given task. Now, what we can do here is, see, let's say there is a day D, there's some day, right? Day, let's say the xth day. Let's consider a day, the xth day, right? On the xth day, which one is better to do? Should I do job 1 or job 2? Let's say both are within deadline, job 1 and job 2. Profit of 1 is greater than profit of 2. So which one should I take up on the xth day? We should always take up profit of 1, right? So this actually hints us towards a greedy like approach, that hey, why can't we just take the ones that has maximum profit and try to do them first, and then later on try have in a better way, definitely in a better way, so that it doesn't affect our answer. It is always the best possible way we can do, right? So what we can do here is so profit and deadline is given to us, right? Now it's not always the maximum profit. Let's say the maximum profit one, we are giving it day 1, right? We are giving it day 1 for the maximum profit one. So let's just consider an example where this will not work like this, right? You cannot just sort and give them like this. So why will it not work? Let's say a maximum profit is there 100, and it has to be completed within day 2. There is another task with a, let's say, with something 4, and deadline is 1 day, right? So if you're giving the maximum profit task the first day, you cannot give this anything, right? But actually you could have scheduled both of them, 100 plus 4, right? 104 would have been your actual profit, but you are not able to give the second one because you have just given priority to the first one. Yes, we should give priority to the first one, but we should not just assign it the lowest possible day that is available with us. So what we should indeed do is, we have to complete our jobs within timeline, right? We have to complete our jobs within timeline. So we will do a greedy like solution. We'll sort first thing we'll do is, we will sort all the jobs with respect to their profit. We'll sort all the jobs with respect to their profit, right? And we'll try assigning them. But when we are assigning them, we have to be clever about their assignment, right? So we will always assign to a day nearest to deadline. We will always assign to a day nearest to the deadline, right? Because let's say the job has to be completed within 4 days. We can try to give it day 4 first, right? We can try to give it day 4 first. That will not affect day 1, day 2, day 3. So if any task has a deadline before day 4, they will not get affected. They can be taken out parallelly, or they can be done as well. But if there are some tasks, let's say day 5 is let's say 5 is the deadline or 4 is the deadline, but they have low profit, so you know that you cannot complete both of them together, so you will just give preference to the maximum profit one, right? So our task is to assign a job to a day which is nearest to the deadline, which is nearest to the deadline, right? Which is nearest to the deadline. And once assigned, this is important, the third step is, once assigned to a day, that day can never be considered again, because that job is will take 1 day to complete. That day cannot be considered again, right? So what we'll do again, what is the logic for this? We'll sort all the jobs with respect to their profit, so the maximum profit will try to assign it. But when we assign it, we know that if we are give it the first day that is available to us, that is actually wrong, right? It is actually affecting our answer. So we'll always try to give it to a day nearest to the deadline available. That is, if the deadline is the fourth day and you don't have fourth day available with you, but you have the third day available with you, you will try to assign it on the third day, not the first day, right? So you will always try to assign it to the third day, because it's your task to get it done. It doesn't matter it is done before or after, right? The third is, once it is assigned to a day. Okay, 1 second. What did I do? Okay, once it is assigned to a day, once it is assigned to a day, we cannot consider that day again, because that job will be done throughout the day, right? You cannot have two jobs running parallelly on the same day. So that's what we have to do. So I'll just write a brute force solution for this for now, and then we'll know how to optimize this, right? So basically what I'm saying here is how to get this done. Let's understand how can we get this done. So first thing that we'll do is sort all the jobs, right? All the jobs based on profit. Now bool will take a boolean array is assigned, will take a boolean array is assigned of size the total number of days available with us, right? So let's say d is the total number of days available with us, which is n. Basically n is the total number of days, right, that is available with us. So n is the total number of days that is available with us. What is assigned? Is assigned of I, is assigned of I is true if a job is assigned to day I. If a job is assigned to day I, right? So what we can do now is, we have sorted the jobs with respect to their profit in decreasing order. So we'll loop over all the jobs. So we'll loop over all the job belongs to all the jobs that are available with us. Now we will start with the deadline. So start time is job dot deadline, right? Job dot deadline. The start time for us is job dot deadline, the deadline for the job, and we will continue as long as we find a day that is not assigned, right? So while not is assigned, start time or time, let's call it time instead. While not is assigned time, so we are starting from the back, from the deadline, and we are going one step at a time, and we are seeing if it is not assigned to that day, if we are able to find a day which is not assigned and is nearest to the deadline, we'll assign it for that day, right? So is assigned for that time is equals to true. We'll set it to be true so that it is not used again, and we'll do answer plus equals to job dot profit and those things, right? We'll do those things. So this is the logic that we'll do. This is again n squared. This is n into d, right? N into d, or n into number of jobs, basically n into j. This complexity. How to optimize this? So if you see this part we are running this loop only for finding the nearest day that is not used yet, right? What we can do is we can maintain a set of all possible days that are available. Whenever we are assigning a job to a given day, we are removing that day from the set. So that will basically do the trick for us. And to find the nearest day from the end, we can use something that we have already know about, lower bound on a set, right, which is the smallest element greater than equal to current element. So we can find the lower bound and move one step back. So that's basically what we'll use to solve this problem, and that will remove completely the second loop, right? That will remove the second loop completely. So that's the logic. So let's look into the code for this now. Let me know if you have any doubts on this. So job is there and n is there, and you're also doing within n days, right? And deadline and profit. So what is the complexity of deadline? Deadline is within 100, right? So that's fine. Okay, we are anyways maintaining a set, right? So int answer equals to 0, int profit equals to 0. Felt like it will be solved using dp greedy sim sus. How to differentiate situations when you have time crunch? To be That's a very good question. That's definitely, I'll tell you, Hemant, that's a very good question. Why? Because everyone considers DP to be the toughest topic, right? But actual toughest topic is greedy. Identifying if a problem is actually greedy, that's the toughest part. How did I identify this? Because I've solved a similar problem before. That's a code chef problem, IPC trainers or something like that. You can check it out. It was, I think, in 2017 May challenge or something like that. IPC trainers, right? So there was a similar problem there. That's why I know it's greedy. How can you prove if a problem is greedy? What you have to do is you have to uh, try to understand how would you do the assignment, right? If you see that with the assignment given to you, you are actually finding a logical proof that it is actually working. It will always work. Like when we are giving, if we are assigning the first day, we always see that it is not working, because I just gave you an example, right? I just gave you a counter example. But the second part, which is assigning it to the nearest possible day to the deadline, that actually is working, because if you think about it logically, you are giving it a day nearest to the deadline that is available, right? So basically it could have been taken up by someone else, but you are giving it to a more profitable job, so your profit is increasing, which is expected, right? So definitely that is a valid strategy that you can take, and you are not affecting any of the other answers that might have been, or any other jobs that might have been a potential answer. So you have to think about it. It's really difficult, but either you have solved the problem before, or you have to think in terms of greedy like solution. Like it seems to be DP, but again, like you have to think in greedy like way, like can I do this? Is this working? If I assign it like this, if yes, why is it working? Why can't it be replaced by any other job? If it can be replaced by any other job, then my logic is wrong. If it cannot be replaced, then my logic is right. So you have to like think in that front. There is no hard and fast rule that, hey, this is the rule it is following, so it is a greedy, right? So again, you have to solve a lot of problems for that to understand, like if a problem is greedy. You might be lucky that you get a similar problem, so that's why you have to solve a lot of problems, right? So int profit equals to 0, and int num jobs done, num jobs equals to 0. So we'll sort first all the jobs, right? We'll sort all the jobs. So we'll take a CMP function as well. Let's take a CMP function as well. Bool CMP job A. We can take the references job A. Or what we can do is we can just sort them. We can just take the jobs in a different array, right? I prefer doing it like this. Pair int uh, jobs. Let's call it jobs. So for int I equals to 0, I less than n, I plus plus, jobs of I equal to what? It is equals to arr I dot profit. Profit is the first property that we want to sort on, and arr I dot deadline is the second property, right? So arr I dot deadline, and then I can just sort, right? I can just sort it safely, and I'll run a reverse loop. It will be sorted in increasing order. We can just run a reverse loop, right? So jobs and jobs plus n. So I can just use the inbuilt method jobs and jobs plus n, and it will do. So I'll just run a reverse loop now for, and also let's store all the days here. So set int, and all the deadline is within 100, right? So set int days, and we can push everything within 100. Let's say within 100. For int I equals to 1, I less than equal to 100, I plus plus, and days dot insert I, right? So for int I equals to 0, I equals to, will start from the end because it's sorted in increasing order of profit. I greater than equal to 0 and I minus minus. Okay, so what do we find here? Int what is the, we know the profit and the deadline, right? So int deadline equals to what? Jobs I dot second. Jobs I dot second is the deadline, right? So we'll find on the days auto IT equals to days dot lower bound. Auto IT equals to days dot lower bound, and we are finding what? We are finding days dot lower bound on deadline, right? So if IT equals to days dot begin. So first is if days is empty, right? If no days left. So if days is empty. So if days dot size equals to 0, then we'll just break, right? We cannot we don't have any day left. Uh, Lower bound. Now if it equals to days dot begin and value at it is greater than deadline, value at it is greater than deadline, then we can continue. Otherwise we can do it minus minus, because we have the first element greater than equal to current element, greater than equal to deadline. We'll do minus minus only if it is greater than, right? So if equal, then it's good. It equals to value at it equals to deadline, then it minus minus, right? It minus minus, if it not equals to, sorry, it not equals to, sorry, it equals to, if it is equals to days dot end, right? If it is to the end, then we have to do minus minus. Or if value at it is greater than deadline, then it minus minus, and then what we'll do, answer plus equals to, sorry, not answer, profit. We can do this job, so profit plus equals to jobs I dot first, the profit, jobs I dot first, num jobs plus plus, num jobs plus plus. And also we have to remove this day from the set, so days dot erase, and we can remove, pass this pointer it, and we remove that, right? So days dot erase it, and what we can return, we can return on vector int answer, answer dot pushback. First is what is the profit and number of jobs done, so profit will be profit, and answer dot pushback, number of jobs, right? Num jobs. I hope that this actually works. Otherwise we have to debug again. So let's see, answer dot pushback, and we have to return answer as well. We have to return answer as well. So I think this part is clear, right? This part is basically we are just looping on all the jobs. We are seeing what is the size of the days. Days contain all the data, like all the possible days that we have. And if it is equals to 0, there's no point, we cannot assign anything. Otherwise we find the nearest date that is greater than equal to deadline. Now if it is equals to begin and the value at it is greater than deadline, then that means all the elements are greater than deadline, so we cannot assign that job, so we'll continue. Otherwise if it is equals to days dot end, or if it is equals to, if it is greater than deadline, then we do it minus minus, right? So then profit plus equals to jobs I dot first, we can do this, and that, right? So compile and run. Let's see if this is running. Okay, jobs I, parent in jobs. Okay, parent in jobs, and it will be an array of size n. Sorry, my bad. Okay, again, job scheduling. Deadline is not there. So what is there in job? Dead and profit. Okay, deadline is not there. Dead is there. So it will be dead. Okay, 62 is the answer. What is the expected one? Our output is 62, and what is the expected one? 62. Output is 260. So we are returning number of jobs, and we have to do it in the reverse way, right? 2 should come first. So let's just do it in the reverse way. Compile and run. Let's see if this is, now this should work actually. 2 and 60 it should give. So we'll submit after this. 260. So let's submit. Okay, it's done. So this is also solved. So this is the code. I think it's clear with everyone, like how we are doing this. Just identifying Okay, I think my net is causing problem again. Yes, just identifying the greedy approach was the trick, and after that, to optimize, we can just use a set because we have to just maintain what is the nearest element greater than or less than the current deadline that we have, and we also once it is assigned to something, we have to remove that from that data structure as well. So that basically suits the purpose of a set. So we have used a set here, right? And all the elements are distinct as well. So I think this is clear with everyone. Let me know in the chat if it is clear with you. Is it clear with everyone? Is it clear with everyone? Is it clear? Okay, I think it's clear. So yes, let's. That's all for today. We'll again meet. I believe the next week or the next week. So thank you guys for joining, and do try these problems. If you're not able to solve it, do try it again on your own and just understand how things are working, and you'll be good to go. Right. So thanks guys for joining.